Alright, so hyperbola is the set of all points x, y. The difference of whose distance is from two distinct fixed points, foci, is a positive constant. Alright, the standard form of the equation of hyperbola with center hk is x minus h squared over a squared minus y minus k squared over b squared equals 1, or y minus k squared over a squared minus x minus h squared over b squared equals 1. Alright? It is unlike the ellipse. The major, or what we call the transverse axis, is not based upon the largest. It's based upon what comes first. So even if this is smaller than that, that's still the major axis. Okay? Your ellipses, your hyperbolas, will pass through your vertices. That's how you know the direction they're in. So sometimes they'll go up and down, sometimes they will go left and right, depending upon which axis is, like we said, the transverse axis. Foci, we go back to having two foci, the formula of which is c squared equals a squared plus b squared. So instead of subtracting, we're going to add. Alright? So today we're going to do the first two problems, and then tomorrow we'll work on finding the equation, and you'll be able to work independently. So, find the center, vertices, and foci, and sketch the hyperbola. X minus 1 squared minus y plus 3 squared over 25. The x minus 1 squared over 16 is equal to 1. Alright, so my center is still the opposite of my parentheses. So what's the opposite of negative 1? 1. What's the opposite of positive 3? Negative 3. So 1, negative 3 is my center of my hyperbola sketch. Then I go to whatever comes first, which is x. That tells me my vertices, like we said, are going to be on the horizontal. What's the square root of 16? 4. So I'm going to go over 4 in each direction. It's going to put me there and there. So those are my vertices. 5, negative 3, and negative 3, negative 3 are my vertices. Notice the y-coordinate remains unchanged. Now, here's what you use the other fraction for. 25. What's the square root of 25? 5. That means we're going up 5 from the center and down 5 from the center. However, instead of an ellipse like we made the last time, we're going to create a rectangle. We're going to create a rectangle. And then what we're going to do is extend the diagonals of that rectangle. Those diagonals are your asymptotes. Those diagonals are your asymptotes. Now, these were the vertices. Your hyperbola curves go through those vertices. So all you need to do is create a curve that goes through the V that then hugs the asymptotes. Alright? All good? Yes, sir. What do you mean by the direction of the arrow? Yeah, it goes on forever in both directions. All right. Everybody else good? All right, so we move over to the next one. This is saying y comes first. All right? Now, what's the opposite of negative 2? 2. What's the opposite of positive 4? Negative 4. Be careful with that. A lot of people will mix those up because the y comes first. So my center is at 2, negative 4. I then look at the denominator of what comes first, which is 4. What's the square root of 4? 2. Because it's the y, that means I'm going up 2 and down 2. Those are my vertices. I then look at my other denominator, which is 36. What's the square root of 36? 6. So I'm going over 6 that way and over 6 that way. Good? I'm going to connect those to form my rectangle. And then I'm going to create the diagonals. Those are my asymptotes. The difference is, instead of the sides, the vertices are now located on the what? Top and bottom. So that tells me my curve goes like that instead. Yes, sir.
Will there always be like two curves?
Yeah. All good? Yes, sir.
So for the first problem, like the vertices are left and right. Why are they up and down? Like how do you?
For this one, whatever comes first. So if X comes first, it's left and right. If Y comes first, it's up and down. Absolutely. That's why I would label those with V when you plot them, so you know. Because you know the curve goes through those. Now, the foci. C squared equals A squared plus B squared. All we're going to do is add our denominators. What's 16 plus 25 in the first one? 41. So C squared equals 41, making C plus minus the square root of that. Just like with the ellipse, let the numbers do the work for you. The y stay exactly the same. So that means the foci affect the x. So I take the center, which is 1, and I put a plus minus the square root of the value I get when I calculate C. And then, like I said, the negative 3 stays exactly the same. So it's 1 plus minus the square root of 41 over negative 3. Make sense? If you look at the other one, if we do the vertices were at 2, negative 2, and 2, negative 6. So this time the 2 is absolutely the same each time. So for my foci, I start with a 2. I then take the center y, which is negative 4. I add my two denominators. What's 4 plus 36? 40. So that means C is the square root of that sum, which is 40, which reduces down to 2 root 5. Sorry, 2 root 10. And then I just bring that down and put it next to the negative 4. With a 2 in front. And that's it. Good so far? All right, flipping on the back. What would life be without completing the square? So 9x squared minus y squared minus 36 minus 6y plus 18 equals 0. Just like with the circle, just like with the ellipse, just like with the parabola, we're going to put variables together. So 9x squared minus 36x minus y squared plus 6y. Oh, we'll just put it, get rid of that. Minus y squared minus 6y equals negative 18. What's the coefficient of x squared? 9. So I'm going to pull that out. X squared minus 4x. And I'm going to complete the square. What's half of 4? 2. 2 plus 4. 2 squared. 4. I'm then going to pull out the negative in front of the y squared. That's going to turn my negative 6y into a plus 6y. What's half of 6? 3. 3 squared. 9. Equals negative 18 plus 36 minus 9. Does everybody understand where the 36 and the negative 9 came from on the right-hand side? Because when I added 4 here, I actually added 4 times what? 9, which is 36. When I added 9 here, I actually added a negative 9. So that's a negative 9. Make sense? I'm now going to factor 9 times x minus 2 squared minus y plus 3 squared equals 9. Just like with the ellipse, I got to have the right-hand side be equal to what always? 1. So I'm going to divide everything by whatever that number that is. For the x portion, what do the 9s do to each other? Cancel out. So I'm going to have x minus 2 squared. Your choice if you want to write the 1 or not. You don't have to. Minus y plus 3 squared over 9 equals 1. What's the opposite of negative 2? Positive 2. What's the opposite of positive 3? So 2 negative 3 is my center. Since the x comes first, my vertices are on the horizontal. What's my denominator? 1. What's the square root of 1? 1, which means my vertex is going 1 over that way, 1 over that way. My other denominator is 9. What's the square root of 9? 3. So I'm going to go up 3 and down 3. There's my rectangle. There's my asymptote from the diagonal. And again, if you know those are the vertices, and you know the graph's got to pass through those, do that, and do that. So it goes back to being going up and down. The vertices were 1 over, so that was 3 negative 3, and 1 negative 3. I look at my denominators, 1 and 9, and add them. What's 1 plus 9? 10. So I got plus minus square root of 10 for C. Since everything's got negative 3, I know that's going to be the y coordinate of my foci. I then take the center coordinate, which is 2, plus minus, and bring down my C. So I end up with an equation of x minus 2 squared over 1 minus y plus 3 squared over 9 equals 1, giving me a center of 2 negative 3, vertices of 1 negative 3 and 3 negative 3, and foci of that. All good? Tomorrow we'll do the last one and work on working backwards, and then, like I said, we'll get your assignment for that.